Okay, so we talked about um, flat belts and round belts in the previous class. Okay, let's see. Let's look at this problem. Um, this problem says that a polyamide A3 flat belt 6 inches wide. So this means that the width of the belt is 6 inches. Okay. Um, and the rest of the specs of the belt are the material of the belt is this, and it is the specifications is A3. It is used to transmit 15 horsepower. ठीक है जी. तो हमारे पास हॉर्स पावर क्या है जो इसने ट्रांसमिट करना है, दैट इज 15 हॉर्स पावर. Under light shock conditions. So, what are the conditions when it operates? That there are light shocks, and Ks due to those light shocks is which is the service factor, that is equal to 1.25, and a factor of safety equal to or greater than 1.1 is appropriate. So we will have a factor of safety. Um, let's call that NF हम क्या देते हैं 1.1, right? And this can also be equal to the design factor. Well, it says that it is equal to 1.1 for now. Let's just keep that 1.1. The the pulley rotational axis are parallel and in the horizontal plane. ठीक है जी. So basically these are the two pulleys that you see in the figure, that they are horizontal. Uh, this is the axis of rotation जो है ये आपके, this is the axis of rotation and here is the axis of rotation. The shafts are 8 feet apart. That means that your center to center distance is 8 feet apart, right? Which if you multiply by 12, that is going to give you the number of inches. The 6-inch driving pulley. So this pulley is the driving pulley, because this is 6 inches, so that is your small d is equal to 6 inches, rotates at 1750 revolutions per minute. So your n over here is 1750 revolutions per minute, in such a way that the loose side is on the top. So this means that it is rotating in this direction, and this one is your loose side. Therefore, your tension on this side must be F2, while on this side the tension will be F1. The driven pulley is 18 inches in diameter. So you have the driven pulley, which is the capital D, because that's the bigger pulley, that is 18 inches. Um, as shown in this figure, the factor of safety is for unquantifiable exergencies. If we say that is for unquantifiable exergencies, that means that your factor of safety is equal to your design factor. ठीक है जी. Now it says that estimate centrifugal tension FC, the torque T. Also find out your tight side tension, loose side tension, the initial tension, and the allowable horsepower. Estimate the factor of safety. Is it satisfactory? So it will be satisfactory if it is more than or equal to the given value that is appropriate. ठीक है जी. So first of all, uh, the center to center distance 9 feet, that is equal to 96 inches. First of all, what would you do is you will find out your theta d. Okay, and we already have a formula for that, which is pi minus 2 sine inverse of d minus d. Okay, this is your capital D minus d. uh, uh, we already have the equation for that, which is equation 17-1. So you will find your theta d, which is 3.0165 radians. Now, as we said, you go ahead and find your exponent of f phi. Now, what is f? F is the coefficient of friction. Okay. So where are you going to get this value for f? This value of f will be from the table, and phi you already calculated that. So let's see if we can find this value from the table. Okay. So go up to the table and see it was poly. This was the material. Okay. And it was A3. And if you go over here, that is your thickness, and then looking over here, this is your coefficient of friction, right? Okay, this is your coefficient of friction over here, so that is 0.8. So go ahead and use this value as your coefficient of friction. Therefore your exponent of f phi will be equal to 0.8 from the table multiplied by this value of phi. So your exponent of f phi is 11.17. Okay. Similarly, the second step, so this was your first step. The second step is to find the velocity. Velocity is equal to pi dn divided by 12. Okay. So this is your pi d and n divided by 12, and you got your velocity from there in foot per minute. Now, again, you can find the weight of the belt by multiplying the density with these two dimensions. Uh, this is going to be your belt cross section. This is your B and this is your T dimension. And gamma for the belt is given to you, which is the density, the weight per unit volume. If I go back to table 17-12, let's see what your gamma is there. Okay, so this is the specific weight, and the specific weight for this belt is 0.42, ठीक है जी, पाउंड फोर्स पर इंच क्यूब. तो 0.42 pound force per inch cube, ठीक है, which is this one, 0.42 pound force per inch cube, and you multiply it with these values. Also, t is also from the table. Multiply it by those values, and you will get the uh, weight per unit foot, because you multiply it with the area. This is the cross sectional area, b times t. So gamma into b into t will give you the weight per foot. Now the third thing is to go ahead and find your FC, which is the centrifugal tension, and that is equal to W by G, V square by 60. So go ahead and put values in there. You found your FC in pound force. Now from the horsepower formula, okay, the horsepower is given to us, and in the previous class, as I told you, okay, the power or the horsepower which is used in speaking, that is known as H nominal. Now you convert this H nominal to design horsepower, yeah, small d, right? And this design horsepower is equal to Ks, the service factor, multiplied by design factor multiplied by H nominal. So this is your design horsepower now. Therefore, from the value that you already have, um, let's say you can find your design factor over here, design horsepower over here, and that will be equal to Ks value. We already have this value, which is 1.25. So the value of Ks is given to us, which is 1.25 multiplied by ND. ND, if you remember, they said that it is for the factor of safety is for exergencies, unaccountable exergencies. So that is your ND basically. So 1.1, the value is given to us, and the horsepower, um, I think it is 15. Okay. So multiplied by 15, and you can calculate your design horsepower from here. Okay. Or you can just put the formula in the equation for torque, yeah, horsepower. So you can calculate your T from here. So this is your the transmitted torque. Okay. Once you find the transmitted torque, uh, as we already know, okay, the necessary F1A minus F2 to transmit the torque. Remember that the torque is transmitted due to the difference in tension of the loose side and tight side. इनके लूज साइड और टाइट साइड के जो टेंशन्स हैं उसी से ही आपका पावर ट्रांसमिट होता है. एंड इफ यू रिमेंबर इक्वेशन 8, व्हेन वी ड्रू द फ्री बॉडी डायग्राम, देन वी वेंट अहेड एंड फाउंड आउट दैट your F1 allowable, the maximum tension, minus F2, which is the difference of the tensions on the loose side and the tight side, that is equal to 2T over D. So go ahead and put the values in there. So now you have this value कि आपका जो F1 allowable minus F2 जो है that is equal to 247.6 pound force. Now from table 17-2, again if you go to table 17-2, let's go up and find out the allowable, the maximum allowable tension in there. ठीक है जी, उसी टेबल में जिससे हमने वैल्यूज लिए थे. इफ यू लुक ओवर हियर, this is the column for the maximum allowable tension. So what is the maximum allowable tension for this type of belt? That is 100 pound force per inch. Okay. So let's use this value, 100 pound force per inch. Okay. So in order to calculate the allowable uh, for the allowable tension, if you remember, we said that the allowable tension is equal to the value given in the table, which is 100, multiplied by the correction factors Cp, Cv, the velocity correction factor, and the correction factor for the pulley, for the belt, where the flexing is, and multiplied, since this F by A, this FA is given in pound force per inch or per unit value of the length, therefore you will multiply this by B to get the value of the tension. ठीक है जी. So that is आपका B जो है, that is 6, and then the FA is 100. For polyamide, your velocity correction factor CV is 1. ठीक है जी. So you will put that as 1, and from table 17-4 you can find the value of CP for this type of belt, which is 0.70, and you can calculate your maximum allowable tension, which is 420 pound force. Right? Now, go ahead and find your F2, because your F2 will be equal to F1 allowable minus F1, because these two are going to cancel with each other, minus F2, which for which you know this value. You already calculated this value, and that value is 247.6 pound force. So 247.64, you put this 420, so now you have your F2 equal to 172.4 pound force. Similarly, go ahead and find your Fi from equation I, that is F1A plus F2 over 2 minus Fc, so you got the value of your initial tension. So this is the value for the initial tension. Now, if you remember, I told you that you have to go and find out your friction that is developed. ठीक है जी. And यहाँ पे जो HD की मैंने बात की थी, we already put the value but we didn't calculate it. That is 1.15 into 1.25 into 1.1, which is H nominal KS and ND. ठीक है जी. So that comes out to be 20.6 horsepower. Now, from equation 17-7, go ahead and find your F dash, which is the friction developed. And if you go ahead and find that, that comes out to be 0.328. Now, you will compare this value with the table. Table 17-2. And if this value is less than the value in 17-2, then you are fine. Otherwise, if this is less than that value, then your belt is not going to work, because the maximum capacity of the friction development, that much friction cannot be developed if the coefficient of friction is value is higher than the one in the table. In this case, the calculated value is 0.328, which is less than the tabulated value. Therefore, there is no danger of slipping. there will be no slipping and your belt will work fine. Okay? Go ahead and find your factor of safety. Your factor of safety will be equal to H design divided by what? Okay, uh, we already talked about uh, this equation. Let me write that down again. Okay, you have your H, okay, which is the the the, the H, okay, and that will be equal to what? That is equal to Ks and dH nominal. Okay. So you can go ahead and find out your, this is going to be your final factor of safety. Okay. So let's call this NF या NFS आप कह दें या NF कह दें. This NF will be equal to HD. Basically, this is your HD divided by your Ks and H nominal. So go ahead and put the values in that equation, and that comes out to be 1.1. Uh, and that this 1.1 is exactly the value which they say that is satisfactory. Therefore, the belt is satisfactory, and the maximum allowable belt tension exists if the initial tension is maintained. The capacity is the capacity is the design power, and that is 20.6 horsepower. Okay. Any question? Any question?
सर ये हमने दोबारा क्यों इफेक्ट ऑफ
ये
सेफ्टी
जी
ये सर हमने ये इफेक्ट ऑफ सेफ्टी दोबारा क्यों मालूम किया तो क्वेश्चन में क्यों आता ना कि 1.1 है
अच्छा जी, क्वेश्चन में इस तरह गिवन था. लेट्स रीड दैट वेरी केयरफुली. ठीक है जी. क्वेश्चन में था कि द फैक्टर ऑफ सेफ्टी equal to or greater than 1.1. So it could have been greater than 1.1 depending on this. ये जो हमारा B है ना, इसको अगर आप ज़्यादा करते हैं तो the factor of safety will basically change. So this is what they asked. They asked us estimate the factor of safety. ठीक है जी. Basically यहाँ पे they are talking about this is the factor of safety that is given to us, but since you are the designer there might be a parameter that would change. ठीक है जी. So they just want to confirm. ज़रूरी नहीं है कि आपको factor of safety दी गई हो and you have to calculate that. ठीक है जी. Let's say for example इस B को मैं ज़्यादा करता हूँ ना तो the factor of safety is going to change. ठीक है जी. And this is the reason they want to show you कि it is not necessary कि आपका डिजाइन फैक्टर और फैक्टर ऑफ सेफ्टी एक जितने ही हो, लेकिन इन दिस पर्टिकुलर केस योर डिजाइन फैक्टर एंड योर फैक्टर ऑफ सेफ्टी आर द सेम. क्योंकि वो कह रहा है ये आपको, लिसन टू द लास्ट स्टेटमेंट, इट सेज द फैक्टर ऑफ सेफ्टी इज for unquantifiable exergencies. This means that in this case your design factor is basically your factor of safety. So but it is not necessary that your factor of safety is equal to the design factor. It can be greater than the design factor. G. Anything else? Achha, one more thing I would want to state, going to the previous equations um, over here. Let's look at this one. Let's look at this equation over here, which is look at equation 17-9. Equation. Now, in this equation, since this came up in the problem, Let's say if this initial tension is zero, what will happen? What will happen to these parameters? If the left hand side is zero, mm, what is the effect? What quantity over here on the right hand side can be zero? ठीक है जी. Can diameter be zero?
Transmitted torque.
Can diameter be zero?
No, sir.
No. अच्छा
No,
जी.
sir.
We already have the coefficient of friction for those two materials, and you will have an angle of wrap. This means that if Fi is zero, that means that your torque transmitted is zero, right? So what is Fi?
Yes, sir.
It is initial tension. Now, in order to transmit torque, ठीक है जी, you need to have initial tension, and this initial tension is, you know, first of all, when you install a belt, there should be initial tension. The second is that you should maintain this initial tension, ठीक है जी, and this should be in appropriate level, appropriate amount, and you should check this from time to time. Okay, this remains the same, otherwise there will be slippage, and the amount of torque that you are expecting from a belt to transmit, it might not transmit that. ठीक है जी. तो if there is no initial tension, this means that your belt is going to slip over the,